Hello, my name is Patrick Clark, and I will be presenting on intent-based networking. Here are some topics we will discuss during the presentation. What is intent-based networking? A brief review of traditional networking fundamentals, an understanding of software-defined networking. We'll go back and discuss more on intent-based networking, some benefits of intent-based networking, some possible challenges to intent-based networking, and I'll provide links as review as well as two journal entries that were used for this presentation. So, what is intent-based networking? Intent-based networking is a virtualized software solution designed to improve networking. Well, that's just a little bit vague, I'm sure. We can get more granular into what intent-based networking is later, but to start with, it's important to understand that intent-based networking is not just a hardware solution. It's a collection of hardware and software working together, but with software taking a dominant role in how data is distributed. The software is going to control more about the networking aspect than traditional networking. As you can see in the slide, both Cisco and Gartner have labeled intent-based networking the next big thing in IT networking. And Cisco CEO Chuck Robbins went so far as to state intent-based networking will redesign networking for the next 30 years. So let's do a brief review of traditional networking. Now, I will attempt to summarize this information without taking us all back to ICTN 2150. As you may remember, the IEEE established 802.3 as a standard in 1985, launching Ethernet as a primary cabling interface. I can remember token ring, I can remember thin net networks. Early on in my career, one of the first major jobs I had was converting a network to a 10 base T network, and it was Ethernet. That was many years ago. What's interesting is Ethernet's still here today. We still use Cat5, Cat6 cabling to connect our networks. Wireless is making great strides. More things are wireless than ever before, and we continue to talk about wireless innovation. But Ethernet is here, and I don't see it leaving anytime soon, especially when you think about the core data center, the network. It is the backbone of everything that is done inside of most networks, WAN or LAN. Hardware switches and routers are remotely distributed in networks, and they use the data and control plane to make choices on how to route data. That's one of the important things about traditional networking. In simplest terms, traditional networking is a combination of hardware and software working together to send data through interlinked computers. However, traditional networking is hardware dominated. Let's take a look at a graphical representation of traditional networking. This slide displays remote distributed network equipment. Let's say these are switches on the same network. To route packets, they have to handle both the data and control transmission. Each switch is required to compute routes, handle forwarding rules, and keep up with changes in topology in the network. Let's now discuss limitations of traditional networking. As you've seen on previous slides, traditional networking is typically hardware driven. To make any significant improvements to the network, you have to change physical hardware. That process is expensive and time consuming. Networks are hard to manage. More than half of the cost of a network is simply in the operation or the administration of that network. Avaya published results of a study that claimed that 82% of the surveyed companies in the United States, Canada, and the United Kingdom experienced some type of network downtime caused by IT personnel making errors when configuring changes to the network core. That's internal users causing issues trying to make configuration changes. The majority of network gear is still command line interface. The hardware of networking has a specific software platform almost always designed for it by the manufacturer. That software platform must be upgraded at times. You also can have code issues with that hardware platform. Any upgrades to that hardware is clunky and slow and almost always require downtime of the equipment to make changes. Some hardware devices are dependent on specific style interfaces, and with the software being specific for each hardware type, there's very limited innovation options in traditional networking. Now let's talk a little about software-defined networking, or SDN. Software-defined networking is based on ideas from researchers at Stanford University in which principles of virtualization was applied to networking around 2010. While at Stanford, the concept was known as open flow. Software-defined networking is based on the same principles of traditional networking, but software-defined networking is slightly different as it's virtualized. The key concept of software-defined networking is the data and control planes are virtualized and separated, allowing smart controllers to manage traffic on the network. The smart controller leverages routers and switches to actually route packets of information. Smart controllers are centrally located, and then they are allowed to control the flow of data and make decisions, freeing the other network equipment to simply route. They don't have to make decisions anymore. Here is a visual review of software-defined networking. This slide is similar to our earlier network view, but as you can see now, the control plane is handled by a smart controller, and switches are allowed to simply process data. This method decreases the time in which the hardware has to calculate routes or handle forwarding rules. The controller makes decisions, the hardware only has to route. Here is another slide. This one has a side-by-side review of the two networks so we can take a closer look. You can see the differences between them quite simply here. On the left is our traditional network with the switch handling both jobs. And on the right, you can see the software-defined network with the controller making decisions and directing the hardware. So let's talk about some major advantages that SDN comes with over traditional networking and kind of its purpose. Primarily, IT services are changing, so must the network. For years, networks have been built in a top-down or tree hierarchical format where a router connects an edge switch, and then that switch connects to two more switches, and then they connect to two more switches, and it propagates throughout the network. That style of connectivity was fine for PC to server to back to PC transactions with straight line north and south traffic, but now networks need to be able to adapt to new and ever-growing technologies. Some of the things we've been talking about in this class: cloud computing, 5G wireless, increased virtualization, big data, the Internet of Things. In this class, we've talked about quantum computing quite a bit on the discussion board. Another concept that's coming where computing processing is increased, but the network has not been leveraged or increased to support these changes. These services require greater throughput. An example of the growth of software-defined networking, this graphic displays how Google has actually converted their entire network backbone to software-defined networking. Let's talk about a few other advantages of software-defined networking when compared to traditional networking. Primarily lower administration costs. Changes can be applied to the smart controller or controllers and then pushed out to each router switch as needed. Administration and operation costs should be dramatically less in software-defined networking as compared to control over traditional networking. Software-defined networking can be adapted quickly to fit specific needs. If changes need to be made on the network, software-defined networking allows you to control things via the controller and make logical changes quickly and when you need to. SDN is cloud ready. It is built on the open platform to allow itself to handle multiple input points from multiple locations versus one single stream of data. It's also more enhanced from a security standpoint. Updates, again, can be applied from the controller and pushed down to the network. So why have we been discussing software-defined networking for the past few slides? And that's because intent-based networking is based on software-defined networking. So let's talk a little more about intent-based networking. Using the principles of software-defined networking, intent-based networking advances the technology. Like software-defined networking, intent-based networking is a software product that allows administrators to streamline data via a centralized controller or controllers on large networks. The major growth in intent-based networking from software-defined networking is the ability to create policies and intent. Intent is a significant term here. The goal of intent-based networking is for the network to be provided enough direction via policies that the ultimate desired outcome is always achieved despite the circumstances. An administrator can create explicit rules that the network will follow. The centralized controller dictates the policies. There could be a policy that knows if a certain style device is installed, it automatically receives the standardized configuration. Intent-based networking allows the administrator to set the controller to understand the routes and allow automatic changes to be made without human intervention. Things like congested routes or oversaturation could be resolved again automatically. As a simple analogy, imagine a well-constructed intent-based network is like a self-driving vehicle and a perfect GPS mapping system all in one. If you wanted to go across town, but the standard route was blocked, this imaginary vehicle would automatically know how to redirect itself to a new route as it understands where the data, i.e. you, needs to get to, and it understands all the routes available. Policies would also cover standard tasks like code push to new hardware, patches to equipment, with security issues, just like software-defined networking. The controller pushes the information real time or scheduled. Gartner reviewed the possibilities of IBNS in 2017 and summarized the product into 4 key categories. Transition and validation. The system takes a higher level business policy, what, as input from the end user and converts it to the necessary network configuration, how. This system then auto-generates and validates the resulting design and configuration for correctness. Automated implementation. The system can configure the appropriate network changes how across existing network infrastructure. This is typically done via network automation and/or network orchestration. Continuing on the 4 key items, awareness of network state. The system ingests real-time network status for systems under its administrative control and is protocol and transport agnostic. Assurance and dynamic optimization remediation. The system continuously validates in real time that the original business intent of the system is being met and can take corrective actions such as blocking traffic, modifying network capacity, or notifying when desired intent is not met. The next slide displays an image provided via Cisco Systems on their take of the concept of intent-based networking. If you follow the slide, you can see how the idea is converted to a policy, the policy is pushed to the infrastructure, and constant assurance is kept in place to confirm the network is working as intended. Now let's talk about some possible challenges to intent-based networking. The concept of intent-based networking has become quite the popular buzzword in the last year, but actual deployment of a fully functional system is still many years away. Pieces of the network will slowly be implemented, but according to Gartner, it will be at least 2020 before someone can fully deploy an intent-based networking organization wide. While intent-based networking is still a few years away from being completely practical inside the network, many technology companies are already promoting products designed to provide these services. This slide shows a few of the vendors who are making products specifically to address the need of customers who want intent-based networking. Cisco and Juniper are the large corporations in this market currently, with Cisco taking the most aggressive approach. They have a diverse platform, offering intent-based networking style solutions for segments of corporate networks as well as the data center. Cisco has branded their intent-based network product DNA, or Digital Network Architecture. I've posted a link to their website where you can find videos on how the products are supposed to work and view case studies. Juniper is building off their already established software-defined networking platform, Contrail, and adding policy management as a solution. Veriflow is interesting as it's a startup based strictly on intent-based networking. Currently, the focus of the company is truly on network segmentation and assurance. They don't offer a single hardware platform. It's an overlay of a software application that will run on your existing network to create the virtualized platform. Apstra is a company again created to support the growing use of intent-based networking. They offer a product named AOS, which is supposed to help you build networks and data centers virtually in half the time. Forward Networks is in a similar situation as Veriflow. They're brand new, they don't offer hardware. In fact, they are selling policy management for network monitoring. This slide displays links to journal entries I utilized with the creation of this presentation. The top link is a study performed by 3 different groups of IBM employees located in Israel, Switzerland, and here in the United States. They resolved that 2 major factors affect if intent-based networking will be successful. One is specifying the network-related requirements. Another is carrying out the requirements of multiple independent tenants in an effective and scalable manner. They also introduced a specialized architecture to achieve these goals named DOVE, D-O-V-E, or Distributed Overlay Virtual Ethernet Network. After reading the study, I now wonder if this was the beginnings of IBM's venture into intent-based networking. That would be interesting, as that's not typically IBM's market space, and it would be intriguing to see them enter and compete with traditional networking powers like Juniper or Cisco. The other study listed here goes into great detail about how software-defined networking is the base that supports intent-based networking and several other technologies that utilize virtualization. The following slides are links to research and references used to create this presentation. Thank you for your attendance. Please let me know if you have any questions I can answer about the topic on the message board.